Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 20, Truncated Cones. Okay, classwork opening exercise says to examine the bucket below. It has a height of 9 inches and a radius at the top of the bucket is 4 inches. So what I'll do here is, what they're saying is from here to here, from here to here, h equals 9 inches. Okay. It has a radius at the top of the bucket of 4 inches. So the top of the bucket is a circle with a radius of 4 inches. Describe the shape of the bucket. What is it similar to? Okay, remember the name of this topic, truncated cones. So suppose I did this. Drew a really long line segment parallel to the side of that bucket there, and then did another one over here parallel to the side of that bucket right there, and then I stopped it at right here. Then what would the shape of this object be? Well, it would be a cone. So then when I take another cut of the cone, if you will, if I cut the cone off here, that's the bottom of the bucket, we cut that part of the cone off and throw it away and pretend that's not there. This is the cone. So a truncated cone, this bucket is a truncated cone. So it's similar to a cone, but it just doesn't have the point, the remainder of the cone that comes together. So if these two sides continue to go in that direction, they would eventually meet right here, and that would have been the point of our cone. So now we want to estimate the volume of the bucket. Okay. So the volume of the bucket, how would we estimate that? So if I were to estimate the volume of this, and I would think, well, it's a cone, and the volume of a cone equals 1/3 pi r cubed times height, or pi r squared times height, not cubed, base area, pi r squared times height, then I would think the volume of the cone would be 1/3 times pi, and the radius is 4 squared times 9. So the volume would equal, and I can get rid of this third and make that a 3, and 16 times 3 pi. So this would be 16 times 3 pi. So the volume is 48 pi inches cubed. Okay, now that would be a cone going all the way down like that. So it's obviously we don't have this volume anymore, so I would say it would be less than 48 pi, but this is an estimate. Estimate the volume of the bucket. We would say at most it's 48 pi, but it's probably less. Okay, so example 1 says to determine the volume of this truncated cone shown below. Okay, so in explaining this, I'm going to bring in this diagram here. So it's the rest of this cone that was cut off. So if I know that this is 8 and this is 10, I don't know what this radius is here. And I don't know this height here, so let's call that x. And I'll call r just r. Okay, so we have a right triangle here for the entire cone, and we have a right triangle that's here for the smaller cone. And the rate of change, or the slope, is the same in both triangles. So this side is proportional to this side, and this angle is equal to this angle, and it shares this angle, so they are similar. So let's start there. So I know that one angle is a right angle, and I know that this angle is a right angle. And I know they share this angle. They're in both. They're in this little triangle, and this angle is also in this big triangle. So I have angle, angle, similarity. So since the triangles are similar, I can set up a proportion. And I can say the height of the little triangle over the height of the big triangle, which is x plus 8, is equal to this radius over our larger radius. So little triangle is to big triangle as little triangle is to big triangle. Okay, but we are told that this r is 4. So it's a radius, and I should just put that in there, because we had too many unknowns and that would not be possible to solve. But we were told that this radius up here, which is the base of this triangle, is 4. So instead of having r in my proportion here, I'm going to put 4. Whoops. Okay, so I have little side is to big side, so it's x plus 8 is this whole side here, equals little side to the big triangle side. And then when I solve this, I cross multiply, because when we have a proportion, we cross multiply. 10 times x, I'll do this over here, is 10x, equals 4 times the quantity x plus 8. So then I simplify by distribution, distribute the 4, and 4 times 8 is 32. And I want to get x by itself, so I need them all on one side of the equal sign, so I'll subtract the smaller one over to the other side, and I get 6x equals 32. Divide both sides by 6, and I get x equals 5. 6 goes into 32 5 times, the remainder of 2, and 6 times 3 is 18, and then it repeats, so it's 5 1/3. I won't use the repeating decimal. It's 5.33333, which is 5 1/3 inches. So that's this piece right here. It says determine the volume of the truncated cone shown below. So now if we find the volume of the whole cone and the volume of the little one, we can subtract them. Okay, so let me just clean this up. I want you to be extremely clear as to what just happened. Okay, we had similar triangles, and I set up a proportion to find this distance right here. So I know that this distance is 5 1/3. And I know that this distance is 8. So the whole thing is 13 1/3. This has a base of 10. So I can find the volume of the whole cone. So let me just erase this for room. We found using a proportion. Now we can get that out of the way. So once I found this piece right here, 5 1/3, I now know the height of the whole cone. And volume of a cone is 1/3 base area, which is pi r squared. I said base area, not Hayseri, times height. Volume equals 1/3 pi r squared times height. So the volume of the whole cone that's not truncated is 1/3 pi, radius is 10, and the height is 13 1/3. Okay, let me rewrite this as an improper. So 13 times 3 is 39, so it's 40/3. Okay, 13 1/3 is 39/3. 13 times 3 plus 1 is 40/3. So volume is 1/3 pi times 10, 40/3. So 1/3 times 40/3 is multiply top times top. We're going to get 40 times 10 times 1, which is 400 pi over 3 times 3. Okay. Okay. so that's the volume of the whole thing, but we don't have the whole thing. I now want to subtract the volume of the truncated cone. And this was 4. So the volume of the truncated cone, or the cone that was cut off and not there anymore, will give us this shape. So it's the whole thing minus this little blue cone equals this bottom piece. So the volume of the blue portion up here is now 1/3 pi r squared times height. And then substitute in my givens. The radius in this one is 4 squared, and the height is 5 1/3, which is 16/3. Okay, so the volume equals 16 times 16 is 256 pi over 9. Okay, so what I want to do now is the volume of the large cone was 400 pi over 9. Okay, I've just noticed something here. I did not square the radius, which is 10 here, so that's 100, so that should be 4,000. Okay, 4,000. Okay, so we have 4,000 pi over 9, and I did square the 4 here and got 16. 16 times 16 is 256 pi over 3 times 3, which is 9. So if we take the volume of the whole thing, subtract the volume of the blue equation here, which is the top portion cut off, we will get the volume of this. So the volume, wow, this thing, I just keep changing colors and it ignores me. The volume equals 4,000 pi over 9 minus 256 pi over 9, which equals 3,744 pi over 9. Inches cubed. And 7 plus 3 is 10, plus 4 is 14, plus 4 is 18, so I know 9 will go into this number, so I can reduce that. And when I do, I get 416. 3,744 divided by 9 is 416. So the answer is 416 pi inches cubed. Okay, in exercises 1 through 5, it says find the volume of the truncated cone. So here's the diagram. See if you can do what we just did, and pause the video, try it, and then see how you did. Okay, so this is telling us what we just did in steps. So we're starting with step A. Write a proportion that will allow you to determine the height of the cone that has been removed. So up here, there's a cone that's been removed. Let me draw that neat with this. Okay, so there's our cone that was cut off. So I don't know this height here. So the proportion of the smaller cone would be the height of the smaller cone over the whole thing, which would be x plus 4, equals 6 over 12. Explain what all the parts of the proportion represent. X is the height of the portion of the cone that's been removed. X plus 4 is the given portion plus the portion that's been removed, totaling X plus 4. The 6 is the radius of the top of the truncated cone, and 12 is the radius of the bottom of the truncated cone. Part B says to solve the proportion to determine the height of the cone that has been removed. So 12 times x is 12x equals 6 times x plus 4. So 12x equals 6x plus 24. Subtract 6x from both sides. And we get 6x equals 24. Divide both sides by 6. And x equals 4. So the portion that's been removed is also 4. And as you can see, to go from 6 to 12, we had to double it. So if this is 4, the whole thing must be double that, which is 8. So if this is 4, 4 plus 4 is the total 8. C says, write an expression that can be used to determine the volume of the truncated cone. Okay, so first of all, I would say volume, let me change colors. Volume equals 1/3 pi r, the bigger one, because we're subtracting, pi r squared times the height of the whole thing, which is x plus 4, or 8. We already know the x, so there's no sense putting the x in. So that'll be 8. Minus 1/3. So this blue portion, let me change colors for this portion. The blue portion is the whole thing with the cone on top that's not cut off. And I will do this portion in green. So the green is going to be actually let's do the purple, is going to be this top piece here. So it's minus 1/3 pi times the radius, which is right here, 6, squared times the height of the little one, which is 4. Okay, so there's our formula. So this is the entire total cone. And this is the truncated bottom. Oh no, not truncated bottom. Remove top. Okay, so we're taking the whole thing minus the removed portion, and that will give us the truncated portion. Okay, so calculate the volume of the truncated cone. Now I'm just going to solve this. So volume equals 1/3 pi. 12 squared is 144 times 8. And I suppose I can just put these in parentheses like so. Minus 1/3 pi 36 times 4. I always like to reduce. 4 plus 4 is 8, plus 1 is 9, so 3 will go into 144, so I can get rid of this 3. And 3 goes into 14 4 times with a remainder of 2, and 3 goes into 24 8 times. So that 144 reduces to 48, so I got rid of my third. 3 will go into 36 12 times, so I got rid of my third. So now the volume equals 48 times 8. 8 times 8 is 64. Carry the 6. 8 times 4 is 32. Plus 6 is 38. So it's 384 pi minus 4 times 12, which is 48 pi. So therefore my volume equals 384 minus 48, which is 336 pi. And I like to use the unit of measurement, centimeters cubed. Okay, number 2, more practice. So you should be able to be fairly quick at this now. I'm still going to draw the diagram though, so you see what we're dealing with. So we have this side That's going to continue up like so. And then we're going to have this side okay. Unfortunately, when I click on this, it covers where I need to draw and it won't let me draw. Let me try it again. Let me just do this and move it. So if I put that right here, drag that up, and drag that up, there's the part of the cone that we cut off. And we also have this base here. Okay, and so they're similar. So we take and we set up a proportion, and if I don't know this height, so my proportion is going to be x over x plus 30 equals, and what does this say? 3 centimeters. So it's going to be 3 over 24. Cross multiply and I get 3 times x plus 30 equals 24 times x. So this is 3x plus 90 equals 24x. Subtract 3x. And I get 90 equals 21x. Divide by 21, divide by 21, and x equals 90 divided by 21. And it's 4.285714286. Okay. So what do we do with that? Okay, I don't like to approximate from the beginning. It throws off our answer. If the sooner you do it, the less accurate it's going to be. So I'm going to reduce this. 2 plus 1 is 3, and 9 plus 0 is 9. 3 will go into both. 3 will go into 21 7 times, and 3 will go into 90 30 times. So I'm going to reduce this. So x is 37ths, and I'm going to use that in my formula. Okay, so now I want to do the volume of the big cone minus the volume of the little. So I'm taking the volume of this whole cone here, and I'm subtracting the volume of this cone. Okay, so the volume equals 1/3 pi radius of the big one, 24 squared times the height. Well, it's 30, and let's make this a mixed fraction. 7 goes into 30. 7 times 4 is 28, with a remainder of 2. And 7 times 2, actually I could just say 4 and 2 sevenths. So that's 7 times 4 is 28, 29, 30 sevenths, yes. So how about I just leave it as 30 sevenths? Just trying to figure out what way's easier. So let's just disregard all that right there. And I'll just put 30, and I'll show you why in a moment. Stay with the color. So this x is 30 over 7. So it's going to be the whole height, which is 30 plus 37. Okay, that's why I did that. Plus 4 and 2 sevenths. So it's 34 and 2 sevenths. Okay, so 34 times 7 plus 2 is 240 over 7. Okay, hopefully you understood what I just did. I just took this mixed fraction and made it improper. 34 times 7 plus 2 is 240 over our original denominator of 7. Okay. All right, so the reason I left it like this is because 3 will go into 240 evenly, and I can get rid of this 3. So 3 will cancel, and 3 goes into 24 8 times, so that's going to become 80. And then I need to subtract the red one minus 1/3 pi radius squared times the height, which is 30 over 7. And this 30 will be reduced to 10 by dividing by 3. 30 divided by 3 is 10. Okay, so now I can finish this. So I have volume equals 24 squared is 576 times 80 pi over 7 minus, okay, 3 squared is 9 times 10 is 90 pi over 7. So I just need to multiply 576 times 80. I was able to do 9 times 10 without the calculator. 576 times 80 is 46,080. Okay, just making sure my number, 46080, 46080 minus 90, 45990. Pi over 7. Okay, now I just want to check, see if that's divisible by 7. So 45990 divided by 7 is 6,570. So the volume equals 6,570 pi centimeters cubed. Okay, so I want to make clear that when you round at the beginning of a problem, your answer is going to be less accurate. So remember when I didn't round this, I could have easily just said that 30 over 7 is, what was it, 30 divided by 7. So I'm just showing you what happens if you round early. So when we got that 4.2857 blah blah blah, and I round that to, and I would say x, if I did that, then I'd say x is approximately 4.3. I rounded on my very first step. So then this 4.3 would have been substituted in here instead of 30 over 7. It would have been right here, 4.3. And since that happens at the beginning, notice my problem is exact. I never rounded, I never estimated. I got an exact answer of 6,570 pi centimeters cubed. I'm telling you this because as you advance in math, accuracy is important, of course. And now watch, I'm going to bring in the key from the teacher's edition. And here it is. Now I'm just going to show you my answer here. Now look what the key did. It said 30 over 7 is approximately 4.3. So then they put 4.3 in their problem here. And then they put 34.3 over here because what was 34.3? 34.3 is this 30 plus that approximate 4.3. So they're approximating two components. Okay? Oops. Okay, so what I'm saying is this 4.3 was estimated, and that's an estimate. This 34.3 is an estimate. So see how they have approximately here and approximately here? And then they took the volume of the truncated cone by taking the volume of the bigger cone minus the volume of the smaller cone, and they came up with an answer of 6,572.7 pi. My answer, I never rounded, ever. I used the fraction 30 over 7 right here and right here. So it was always totally accurate. And why wouldn't you when you have this 3 that would cancel this 30? Okay? And I got an exact answer of 6,570 pi centimeters cubed. What did they get? 6,572.7. They are over by 2.7 cubic centimeters. My answer is accurate. Theirs was an approximation, and they were off by 2.7 pi centimeters. Okay? And remember that that's being multiplied by pi, so that makes their answer being off even more, because then you multiply this by 3.14. Okay? So if I go in my calculator and say 2.7 pi is 8.48, that's how much they're off. They're off by 8.48 square centimeters by estimating. Okay, so please do not estimate until the very last step. Your answer should be 6,570 pi centimeters cubed. Okay, so now we're moving on to a truncated well, this is a square. It was a square pyramid, and when they truncated it, now they've got this square pyramid truncated. Okay, so if we continued up, okay, I'm just trying to show you what got cut off. And I'm just focusing on the right triangle inside that design that tells us what our dimensions are. Okay, so this is a 1. So we have a right triangle, large one, including the red, and then we have the little red one on top. And that's the two triangles we're going to work with right here. So I'm going to set up a proportions, just like before. And I'm going to say, I don't know this, so it's x, okay, the height of the little red triangle as to the height of the whole thing, which would be all the way down here, over and up, which is x plus 22. And that equals the base of the little one over the base of the big one. I cross multiply, so there's the proportion. Find the volume of the truncated base. This is actually supposed to go right here. Write a proportion that will allow you to determine the height of the cone that has been removed. Explain what the parts of the proportion are. Okay, so you'd want to say that x is the height of the small triangle that was removed, and x plus 22 is the height of the whole thing, including the part that's been removed. This is the base of the right triangle of the part that's removed, and this is the base of the pyramid down here. Okay, now it says to solve your proportion. So 5 times x is 5x equals 1 times x plus 22. So that's just simply x plus 22. Subtract x from both sides, and I get 4x equals 22. Divide by 4, and I get x equals 5.5 meters. So this little piece up here that's cut off, they cut off 5 1/2 meters. So the whole side is 5 1/2 plus 22, which is 27.5 meters. Okay? Write an expression that can be used to determine the volume of the truncated pyramid. Remember, the pyramids are also 1/3 pi r squared. So volume is going to equal the volume of the whole thing, which is 1/3 pi, radius of 5, squared, times the height, which is 27.5. Let me put that in parentheses so the decimals aren't confused. Okay, minus the red portion, so I'll do this in red, minus 1/3 pi, the radius of the little one is 1, squared, times the height, which we found to be 5.5. Okay, so there's the expression. Now it says to calculate it. Okay, so rather than rewriting this, I'll just simplify it starting down here. Volume equals 1/3 pi 25, 5 squared, times 27.5, minus 1/3 pi, 1 squared is 1, so that's 5.5. Okay? And now I'm just going to calculate this. Okay, so I guess the easiest way would just be use your calculator. So I'm going to multiply 1/3, and remember fractions should be in parentheses, so it does order of operations correctly, times 25 times 27.5. Okay, and that's going to give me 229. Now remember, I'm not going to round yet. And what is 0.16 repeating? So I'm going to do that and check, see what that is. If you don't know, oops, I forgot my 0.1. 0.1. Now with a TI calculator, if you hit a repeater until it goes off screen and hit enter, and then hit math, enter, enter, it'll tell you the fraction. So that's 229 and 1/6 pi minus and 1/3 of 5.5. So 5.5 divided by 3, same as multiplying by, it's 1.83 repeating. So it's 1. And what is 0.83 repeating as a fraction? So I could do 0.83 and hit 3 a bunch of times till I go off the screen and hit enter, and then hit math, enter, enter, and that is 5/6. So that is 1 and 5/6 pi. So 229 and 1/6 pi minus 1 and 5/6 pi is going to give us an answer of our volume. So 1/6 minus 5/6 is negative 4/6, which is 2/3. Okay, so we're going to subtract 2/3 from our whole number. 229 minus 1 is 228, minus another 2/3 is 227 and 1/3 pi. So I'm going to check that now. 229 and 1/6. 229 plus 1 divided by 6, I'm just putting it back together, minus 1 and watch order of operations. And I got 227 and 1/3 pi. Unit of measurement, meters cubed. Okay, one mistake I did make here was I used the volume formula for a cone. And remember that if this is 5, this has to be 10 by 10. So our bases are side by side squared. So this is 2 and that's 2. So instead of having, I just need to fix this. Okay, so it's 1/3 pi base area. I have 25. I did the radius, like a radius. So instead of that 5, I should have 10 by 10, which is 100. So this 25 should be 100. So let me just fix this. Okay, base area is side squared, 10 squared. I did radius squared. So now when I look up here, this is 1, so the whole side is 2 by 2, which is 4. So I need a 4 over here, not a 1. So I'll just put the 4 right here. So I need to multiply that by 4. And multiply this by 4 as well, because I had 25. So let me just fix this. So 1/3, I'll ignore the pi, we'll leave it in terms of pi. 100 times 27.5 equals 916 2/3. Minus, and then 5.5 times 4 is 22 thirds, which is 7 times 3 is 21, 7 and 1/3. Okay, so then we get the volume equals 916 minus 7 is 909. And 2/3 minus 1/3 is 1/3 pi meters cubed. Okay, I apologize for that. This is my base area, which equals side squared. I did radius like it was a cone. 909 and 1/3 pi meters cubed. Okay, number 4 says, a pastry bag is a tool used to decorate cakes and cupcakes. Pastry bags take the form of a truncated cone when filled with icing. What is the volume of the pastry bag with a height of 6 inches? So if we have a cone, I always like drawing a picture. We have a cone with a height of 6 inches and a radius of 2 and a small radius of 0.5. So they're saying that this is a truncated cone. So then we have a top that looks like this. And we have a height of 6 inches. Okay, height of 6. And a large radius of 2 and a small radius of 1/2. Okay, let me just draw that out here. Okay, so the only thing we don't know is the height of the truncated portion, x. So the first thing we're going to do is say x over the whole thing, which is 6 plus x, equals 1/2 over 2. Cross multiply. 2x equals, and 1/2 times 6 is 3 plus 1/2 x. Subtract 1/2 x from both sides, and I get 1 and 1/2, or 3/2 x equals 3. Multiply both sides by 2/3 and we find our x. These cancel. X equals, these cancel, 2. So this piece up here is 2. So that means the whole thing is 8. So we take the volume of the whole cone. I'll do that in blue. Actually red. So we have we have an entire cone here, or a right triangle in the cone, and then we have the little one up here. So we're taking the volume of the whole thing, which equals 1/3. Base area is a circle, pi r squared, times the height. And the radius is 2, times the height, which is 8. and we're going to subtract the little blue area, or volume, which is 1/3 pi, radius of 1/2, squared times the height, which is 2. Okay, now we just need to simplify this equation. Volume equals 1/3 pi. 2 squared is 4 times 8 is 32. Minus 1/3 pi. 1/2 squared is 1/4 times 2 is 1/2. Okay. And then we simplify. 32 thirds is 10 with a remainder of 2. So it's 10 2/3 pi. 32 divided by 3 is 10 2/3. Minus. And 1/3 times 1/2 is 1/6 pi. So I'm going to change this to 4/6 so we can subtract. Okay, so our volume is going to equal 10 4/6 minus 1/6, which would be 10 3/6, or 10 1/2 pi inches cubed. Okay, now it says explain in your own words what a truncated cone is and how to determine its volume. So you should have something like this. A truncated cone is a cone with a portion of the top cut off. The base of the proportion that is cut off needs to be parallel to the base of the original cone. Since the portion that is cut off is in the shape of a cone, then to find the volume of the truncated cone, you must find the volume of the cone without any portion cut off, find the volume of the cone that is cut off, and then find the difference between the two volumes. That difference is the volume of the truncated cone. Okay? So all they're basically saying is, you have a big cone, you cut the top off, the volume of the whole thing without it being cut off, minus what you cut off, is what you truncated. Okay, that is the end of lesson 20. Review this lesson summary and go do your problem set.